So good morning. So I want to continue the lesson, but I don't know how many of you have seen the questions that I have published for problems in this lesson. In one of those lessons, I hope that I'm not lagging behind. In one of those lessons, I asked you to use GeoGebra to find the locus of some particular point. I want you to see that feature in GeoGebra. I think this is interesting to see. So the question was this. Let me just sit down here and then try to do it. Okay. So the question is, if I have a circle, so let me just have this circle, for example. Any circle here, for example. And then let me. Okay. So yeah, that's good. And then I make a triangle so that one vertex is moving on this circle, and then the base is fixed. For example, I will take this one and then draw this. Sorry, it happened. Okay. I don't know. For example, this triangle. My point is to keep this CD base fixed, and I want to let B moves on this circle. And then I am asking you, what is the locus of the centroid? Is that understandable? So for example, if I want to find the centroid, I go here, and then I find the midpoint between these two. Yes. And then I draw I also find the midpoint between these two. And then if you remember what we discussed before, this would be one median. Yes, and then this would be another median. I don't need to draw the third one because the third one also passes through this point. So this point is the centroid. Yes, agree? Mm-hmm. So I go here and find the intersection point between this line and that line. Yes. So this is the centroid. So my point is what happens if I start moving this on the circle. Oops, I don't know why the circle is changing. The circle shouldn't change. Or might be that's not a good idea to start working with that, because it will affect this side. So let me do it once more. Do you have any idea how can I clean everything? Yeah, in setting. No. It should be in edit. Yes. Do you see any edit? Yeah. So I don't want to. So anyway, my question, because the problem is that when I am doing this, I have chosen the wrong point. This is also affecting the size of the circle. The size of the circle is supposed to be fixed. So what can I do you think? I can make this point disappear, yes. No, disappear. Yes. And then I will choose another point of my own here. Hopefully this is exactly the same point. Okay. Now I think this will work, yes. This hopefully will not affect. No, this does not work. Okay, we shouldn't be lazy, we have to do everything from scratch again, so let me just get rid of them. So here I will take a circle, yes, a fixed circle. This time I will not make that mistake, so let me first immediately get rid of this show object. Okay. Now let me take a point myself anywhere here on the circle, and then let me make this triangle. Okay, so this is the triangle that I want to make, and then I will go and find the midpoint as before. So let me just do it quickly, and then another one here, and then I will take this line segment, connect this one to this, and I will connect this one to that, yes? And then I find the intersection between the medians, and this becomes the centroid, yes? Okay, so, of course, the wrong name. Usually we call it G, no worries. But this H is the centroid. Now, hopefully this will work, this side, without affecting the sides, yes? Now, you see, when I start moving this on this circle, this centroid is also moving around, yes? My point the one question I ask you to demonstrate the locus of point H using GeoGebra to find an idea what would be the locus and then try to prove it. It's a golden level problem, yes? So, and I think I want you to learn how to do it with GeoGebra, if I remember. By the way, we don't need to have these things, so we don't need this, oops. Yeah, I want to get rid of only this one, but I don't know why everything disappears. Do you know why? Because it might be everything is highlighted.
You can select it on the left side.
Yeah, where is that? CF. Segment CF. Where is segment CF? Do you see that? I don't know, because it should...
The gray one, F equals segment CF.
F equals segment, okay, so I get rid of that, thank you. And the other one, DG, where is DG? Yes, this one. And then I don't need the points, yes. But we know that that point, what is the point? So I just get rid of this point as well, and this point as well. Okay, let us see it works or not, yes. But we know that every time when I am changing this C, I have a triangle. But if I ask you what is H, this is the centroid of this new triangle when I start moving it around, yes? And then there is a feature, if I remember correctly, it's called the locus, you see? Yes, here. Yes? So I want to find the locus of point H when C moves. So that is the locus, yes? So that was a nice feature, I discovered that, so I ask you to use this one. So it means that when I start moving this, yeah, that's actually moving there, yes? So it was not probably easy to guess when I start moving C on this circle what happens for the centroid, but now we have a better understanding of what is the meaning of the locus, yes? So if I start moving things around, and I think you can also play it somehow, yes or no? Yeah. So at least this was actually something interesting. So you could understand it. So is that clear? So at least if of course we cannot be sure 100% this is a circle, because if it deviates, I don't know, 1%, our eyes cannot detect that. But at least it seems that this is a circle. Yes? And of course, I don't know if I can highlight this. Where is that? Oh, okay, it is not written. What is this one? I think this is my circle. Okay, so I don't know. But I was able to prove that this is a circle. I mean that just using this demonstration, you cannot be convinced that this is indeed a circle. Yes, because it might not be the case. But I was able to show mathematically that yes, this is a circle. And if I claim that the locus is a circle, I have to specify the center of this circle, and I have to specify the radius of the circle. Yes? Is that clear? Okay, but something that is very interesting when I was just checking, so I mean that you can learn a lot with GeoGebra. The point is that if I start, let me see if I can change this one. You see, when I change this, it is very strange. The location of the locus is changing, but the size is not changing. Yeah, this was not, I wasn't able to see this before, but now I understand everything mathematically. But then if I start making this circle bigger, I don't know. You see, the radius depends on the radius of the circle, but not the position of the base. Okay, so that was a nice discovery, yes? So you should be able to discover this one and to see why this is a circle. Okay? If you don't mind to understand this better, let us do the same problem, but instead of looking at the locus, let us look at the center of the inscribed circle. Do you remember where was the inscribed circle? Where was the center of the inscribed circle? So if I want to get rid of them, So what should I do? Let me just do it from scratch again. Select all and then we delete. So now my question is, I want to do the same thing, but then it becomes a little bit mathematically harder, you will see, but it would be interesting. I was able to also find this, but it was not easy geometrically. I couldn't find a geometrical way of doing that. Okay, so let me get rid of that one again. Show object, and then let me choose a point here, any point that you like, and then let me make this a triangle. So do you remember where is the center of the inscribed circle? Where was it? Do you know that you remember that we can draw a circle inside the triangle so that it touches the sides at one point, yes? That is called the inscribed circle. So if you remember, I don't know, it is the point of concurrency of the internal angle bisectors. Yes. So for example, if I go here to angle bisector, and I draw the angle bisector of this angle, yes, and then I draw the angle bisector of this angle, yes, and then do you remember, this is the center of the circle which is inside the triangle and is tangent to these sides. Yes, but I don't want to draw that circle, that's not my point. My point is to find the locus of this when it is changing. So I will find that one. Okay, and then I want to get rid of these lines. So let me delete this. It takes this F away. Okay, so show object. Okay, and then show object. So this point is the center of a circle that if I draw it, it will be tangent to these sides. That's the center. And then if I start moving this, I don't know, what is your guess about this? What will happen now? If I start moving, of course, it is clear that F also should move. Yes? But let us see what GeoGebra offers for the locus. Yes? So we go to this one, and then we choose this, and then that. So that's a crazy locus, yes? It's not an ellipse. It's not, at least it doesn't seem like an ellipse. It doesn't seem like a circle. So this is a very strange curve. So, but for the median, it was easy to detect probably by our eyes. It should be a circle. But in this case, what is this called? I don't know. Is there a name for this kind of thing? And then what will happen if I start moving things around? This also moves here. But could you predict, this is the important question, could you predict it should be a closed curve? What do I mean? For example, it might happen that F starts from somewhere and just go randomly around and stops here. Do you think this will be possible? Could you predict before seeing the locus that whatever the locus is, it should be a closed curve? Could you see why?
Because when it goes a full round
and go back to the same point, that point should return to itself, yes? So either it should be a line segment going back and forth, or a piece that it goes back and forth on itself, or it should be a closed curve, yes? So predicting that that's a closed curve is not that hard, but what is this closed curve name? I don't think there is a particular name for this curve. But then the question is that, can I find an equation for this curve? Then it becomes analytic geometry. In principle, I think we should be able to solve that in the future. I don't know, I haven't checked that. But anyway, this is a nice feature of GeoGebra, how to use the locus. And I think this gives you a little bit better understanding of what is the meaning of the locus, yes? Is that clear? So now this, of course, in the previous question, in one of those problems, I have asked you to prove that the locus is the circle, and the circle, I ask you find the center and the radius of that. Okay, and of course, you shouldn't trust your eyes. Let me also tell you that, yes, this is also a good question if I remember how to make it here. So let me ask you one question. 1, 2, 3, 4, 5, 6, 7, 8. I want to make this triangle. Hopefully I remember the numbers. I don't know. 1, 2, 3, 4, 5. Yes. Yes, this one. And a polygon. So let me draw a triangle, a rectangle here for you, and then I can change the color here. For example, red 1. Good. Oops. Yes. Okay. So let us use the features here in GeoGebra. Here, I want to ask you to find the colored area. Of course, this is a Grundschule problem, but because this is simple, let us ask GeoGebra to do it for us. I don't know if we can do this. So the area, so I click here, so the area is 12, yes? Is that right? Because 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, I multiply, it becomes 24 divided by 2, so the area of this is 12. Now let me choose this area, it is 15, agree? 1, 2, 3, 4, 5, 1, 2, 3, so that area is 15, and then I do the same thing here, the area is 5, am I right? Yes. But now, I don't know if I remember the numbers correctly or not, but now let us, so if I ask you what is the area would be how much? 32. Yes? But now why this is not, let us see, let me complete this rectangle. Okay, what is the area of this total rectangle? What is that? 1, 2, 3, 4, 5. And how much is this? 8 is what? 40, yes? Am I right?
It's 5 times 100.
That's right. 1, 2, 3, 4, 5. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. If I multiply them, it becomes 65. Yes?
What's 65?
But then divided by 2, it becomes 32.5. Yeah, is that understandable what I'm saying? It's a little bit contradictory, isn't it? Because I added them, it becomes 32.5. Am I right or no? 32. But when I divide by 2, I should get 32 again, but I get 31.5. Or 32.5, sorry. Yes. I'm confusing you. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. 5 times 13 is 65. Divided by 2 is 32.5. But when I add these, it becomes 32. Where is that 0.5 coming from?
Den översättningen lutar. Jag kan inte säga det här på engelska.
I can guarantee you that I am not cheating with numbers at all. If you don't trust, you can write on the papers. I can guarantee no cheating is going on for numbers or calculations. Everything that you see the calculationally is correct. But what the problem is? Yes, Jonathan?
Maybe it's because it's not the whole triangle, because from A to E it's not A to C and C to E.
Yeah, exactly. So I wanted to, you cannot trust your eyes, because this line from A to E is bent, is broken. It's not a straight line, and if you don't believe, you can just do that, yes? You go from here and there. This deviation is so small that you cannot detect. That's the reason that I told you that even if you see that this seems like a circle, there is no guarantee that this is indeed a circle. A mathematical circle should be 100% a circle, yes? But the deviation is so small that you don't see this with your eyes, and then this is the matter of confusion. So these numbers are actually nice numbers, so because they were so close that your eye couldn't detect the difference between the slopes. Yes? So if you see, and now if I ask you what is the area of this thin triangle that you see here, is that 0.5. Yes? So this is why I'm saying that if what you see, you shouldn't trust your eyes unless you have a mathematical proof that this is indeed the case. Okay? Okay, so I just wanted you to know about this feature of GeoGebra, which I think is a very interesting one, and you can do a lot of things yourself. Okay? And I have given you some questions. For example, I don't know, draw, using GeoGebra or whatever, draw a triangle that the midpoints are clear. So how can you go from the midpoints to the triangle? I have given you some exercises. I don't know if you are following or not, but I would recommend you to see at least some of them. Okay, let us now go back to our lesson.
Där. På första triangeln. Och vinklarna på andra är samma. Och det kan du dra slutsatserna. Meningen är inte samma. Det ser ut som det.
So, so the dot product of vectors continues. Definitely we will finish this part, this section, this week, yes? So, let me see, what was the question? Let's say, U is equal to, yes. So there is one question left from this one. I don't know how many of you have worked on it. So the question is this. We had two vectors, u and v, and I have given you that norm of u is equal to norm of v. This was the information given. And then we know that 5u minus 4v, this vector is perpendicular to the vector u plus 4v. And then I have asked you to find the angle between u and v.
Is it 4v or?
No, what is you?
I wrote 2v last lesson, but
2, yes, that's correct. That's correct. But of course, it doesn't matter. It might be this will affect this angle, of course. Okay, so what is your suggestion to solve this problem? I don't know if you remember, there is a very big gap between the previous lesson and this lesson. Hopefully, you haven't totally forgot everything, yes? So let me just remind you. So how this perpendicularity is related to the dot product of vectors? Do you remember this one, which was very important? So what was the dot product in the first place? Do you remember? So if I have two vectors A and B, if I want to dot product them, so it becomes by definition the norm of the first vector multiplied by the norm of the second vector multiplied by the cosine of the angle between these two vectors, yes? So I told you that there are some questions that directly asks you to calculate the dot product, but sometimes they are not asked directly. You need to know yourself that you should be able to use the dot product notion here. So here, this is one of those cases. if none of, so if this dot product is equal to 0, it means that either the first one if the first number is 0, or the second number is 0, or the third number is 0. But if I tell you that A and B are non-zero vectors, then there is only one possibility left, and that is this equals to 0, and then this means that the angle is 90 degrees, yes? So whenever we want to talk about perpendicularity of two vectors, you might remind yourself about the dot product, even though in the question they haven't asked you to do it directly. Okay? So from this assumption, what can I conclude? I can conclude that if I dot product this vector with that vector, the answer should be 0. What type of 0? Is this the 0 number or the 0 vector? Number, because this is the first operation that we learned. The output is a number, not a vector. Yes, I give you two vectors, you do something, but the output is a scalar, is a number. Okay, and then you remember that we had distributivity, so I can distribute that. So let me just remind you. So this means that 5u dot u, and then I told you that you have to write this dot. And then 5 times that, it becomes plus 10 u dot v. And then this becomes minus 4 v dot u. And then we have minus 8 v dot v is equal to 0. Yes? Do you remember I told you that there is a famous relation that you need to remember when you dot a product by itself? Yes?
The norm of u squared.
Is squared. Yes. So this becomes 5. The norm of u squared, but you learn that there is no difference between u dot v and v dot u. This operation in vector, in the set of vectors is commutative. So then it means that I can write it simply as 6 u dot v, and then I have minus 8 norm of v squared, and that's equal to 0. Yes? But still, my question mark is the angle between them. So far, I do not have this involved, but then I realize that I can use the formula for the definition of u dot v. So I can write as 5 norm of u squared plus 6. This I use the definition, norm of u, norm of v, and then cosine of the angle between these two, minus 8 norm of v squared is equal to 0. I don't know, have I mentioned in the problem, I should have mentioned that these vectors are non-zero vectors. By the way, because if these vectors are 0 vectors, if both of them are 0 vectors, then this becomes the 0 vector and this becomes the 0 vector, and the 0 vector is perpendicular to the 0 vector doesn't make sense because the vector is just 0 vector is a point. Is it possible that one of them is 0, the other one is not 0? For example, let us assume that v is 0 and u is not 0. Then it means that 5u is perpendicular to u. Okay? When this can happen? Is it possible that 5u is perpendicular to u? We know that 5u is parallel to u. If it is also supposed to be perpendicular to that, it means that u should be the 0 vector. So it means that you really don't need to say that u and v are non-zero vector, because when I write something like that, automatically it means that u and v are non-zero vectors. Okay, so why I emphasize that? Because now I know that the norm of u, whatever it is equal to the norm of v, so I replace everywhere that I see the norm of u, the norm of v with the norm of u. So I will keep this one, and then this becomes 6 norm of u squared, because norm of v and norm of u are the same. Instead of norm of v, I put norm of u. And then cosine of the angle, which is still not known. And then I can write 8 norm of u squared again. Yes? Is that understandable? So here, norm of u is equal to norm of v given in the problem. Okay? And then I can divide by norm of u squared, everything. Why? Because I told you that assuming that u is not the zero vector, this is non-zero, so I can divide everything by this. So it becomes 5 plus 6 cosine u and v, and then minus 8 equals to 0. But 5 minus 8 is minus 3. I move it to the other side and then divide by 6. So what happens? Cosine of u and v is equal to 1 over 2. Agree? Okay. But then this means that the angle is known because, of course, this is not Math 4. In Math 4, you have to find all the angles. But here we know that u and v are vectors, and this is the angle between two vectors, and the angle between two vectors is somewhere between 0 and 180 degrees. So it means that I want to find an angle between 0 and 180 so that its cosine is 1/2, and there is only one angle with that property in that interval, yes, and that is 60. Or now you can write it in radians. Yes. Okay, so that was one question that we had. So now that I refreshed your memory, so that probably you can solve some problems yourself now. Okay, let me give you another question. I want to wait a little bit for you so that you can answer the question. Example. Let u and v be non-zero vectors such that okay, let me see, u plus 3v is perpendicular to 7u minus 5v, and u minus 4v is perpendicular to 7u minus 2v. Let me double check because these numbers are important. So a u plus 3v, 7u minus 5v, and u minus 4v, 7u minus 2v. Yes. We know that these two are the same, so these perpendicularity relations hold. And then I want to determine the angle between u and v. So I told you that whenever you want to calculate the angle between two vectors, you need to think about the dot product. Maybe that is the answer. So that would be the good strategy. Okay, so I will pause recording the video for 5 or 6 minutes, and then I want you to think a little bit about the problem. Okay, any results? Something that is good to use, because I see that okay, let us try to do it together at least. Okay, I don't think you have problems translating them into the language of dot product. So the first assumption tells me that u plus 3v. By the way, at this level, you should be more comfortable with algebra, okay? Yeah, you need to have a strategy in your algebra calculation. So let us see, this is 0. And if you don't mind, let us not waste the time and then do it quickly. So this one times that one is 7 norm of u squared, yes? And then this one we can do it in our head. This is minus 5 times. This is 21 times. So it becomes 16 times, yes? So this becomes 16 u dot v and then this one is minus 15 norm of v squared. It's equal to 0. This is one relation. Another one is that u minus 4v is dot product with this. This is also 0. But then this will give me 7 norm of u squared minus, this is minus 2 u dot v, this is minus 28, so correct me if I'm doing something wrong, and then this becomes plus 8 norm of v squared, yes? Am I right? Did the numbers, did you also get these numbers? So this is so far so good, but the point is that we want to determine the angle between u and v. Okay, then what we should have a strategy actually. So what is your strategy? Because if you want randomly do some algebra, it might work, and it usually doesn't work. Okay, so do you have a strategy? So because you want to find the angle between u and v, so in principle, you need to know a little bit about u dot v. Okay, so in this form, of course, I wouldn't say how many unknowns. How many unknowns you see in these two equations? This is not a very good mathematical question, but you see this relation is involved with 3 parameters. One of them is this expression, the other one is u dot v, and the other one is this one. And the same equation is here. So the same terms are also involved here. So in principle, you can think about it that I have 3 unknowns, but how many equations do I have? 2. So you shouldn't be optimistic that using these 2 pieces of information, you can find a number for this, a number for that, a number for that. Yes? But you can find, definitely, you can write 2 of them in terms of 1 of them. This is the general strategy. This is what I want you to learn. When you come to math specialization, your mathematics should be more mature, so you should be able to think in this way. So here, I have 2 relations, but I have 3 parameters involved, so I shouldn't hope for finding a number for each one of them. It is not possible. But I can assume that one of them is given to me and try to find 2 of them in terms of the other one. Yes? Because, for example, if you assume that u dot v is given to you, then you are left with a system of 2 unknowns and 2 equations. And in principle, you can solve it. Yes? So be careful. I want you to understand, when you were working with 2 equations in 2 unknowns in Math 1C, that is the same idea that I am using here. But you need to understand how to use the ideas. Okay, so now which one do you think it would be a good idea? So which one do you think that would be a good idea to? So I think might be that's a good idea to find norm of u squared and norm of v squared in terms of u dot v. For example, yes? So what can I say? Okay, I can make a system of equation for myself. I'm just trying to think loudly so how you can understand how I think, yes? This is the way that I think. I do not randomly manipulate the algebra, yes? Because we should have a strategy. So I would write this equation, minus 15 v squared, and by the way, because I am lazy, so let me just write, norm of u, let me simply write u without this vector, and then norm of v, let me call it just v. Yes? Is that understandable? Okay, now let me write this. So then it becomes 7u squared minus 15v squared is equal, I move this to the right, it becomes minus 16.u, u dot v. And then another equation I have here, 7u squared minus what? Plus 8v squared is equal to 30u dot v. Yes? Is that understandable? If you don't like because I was lazy to write all the time this, I just use this one. But this is the system. But don't get confused. These are your unknowns, and whatever this is, I am pretending I know it. It's just the right-hand side. And I want to solve the system. Is it hard now? How can I solve the system? I want to get rid of u to find v, and then get rid of v to find u. Getting rid of u is very simple, so let me multiply this by minus sign and add it here. This minus 7u squared and this 7u squared disappear. This becomes positive 15. When I add it here, it becomes 23v squared. And then I multiply this by negative and add it here, it becomes 46. Yes? And then what was my goal? My goal is to find v squared, so I divide by 23. So then what I get a relation. Yes? Okay, and now that I know v squared, I put it in one of them to find the other one. Yes? So for example, which one? Let us put it in this equation. Let me write here. So this becomes 7u squared plus 8 times v squared. 8 times this is 16, u dot v. And then plus 8u, what I did? Yes, sorry. Yes, I did correct. 7u squared, 8 times v squared is 30 u dot v. Yes? And then I move it to the other side. So 7u squared becomes 14 u dot v. And I divide this by 7, it becomes u squared is 2 u dot v. Yes? So you see, you should have a strategy, otherwise might be, if you do randomly, it will work, but usually it doesn't. So at least I understand something. These two vectors have the same norms. Yes? Because v squared is 2u dot v, and v squared and u squared is the same thing. So the norm of u and the norm of v are actually equal. So from this, I can realize that, okay, forget about these things. What was my general strategy? My general strategy is to, my general goal is to find the angle between u and v. So what can I do now? So you see the problem becomes much simpler. So the algebra goes very smoothly, not that hard. If you have a plan what you are doing. Okay, what can I do now? My goal is to know about the angle between them. So it means that I should use the definition somewhere. So let me use the definition here, for example. Let us see what happens. So I would say that v squared is equal, and so let me just go back to the normal. Now everything is finished. So norm of v squared is equal to 2u dot v. Agree? This is what we got here. I switch back to the old notation. And then I would write norm of v squared is equal to, what can I write here? It becomes 2 norm of u, norm of v, cosine of the angle between them. Yes? And then what? Everything becomes clear, yes? Because this norm of v, I can divide everything by this one, because they are said to be non-zero vectors. But now I also learned that this one and that one are also equal. Yes, that was a coincidence of these numbers. So what happens then? I can also simplify this with the left one. So this becomes 1 equals to 2 cosine u and v. And the same story, yes? So this means that the angle u and v is how much? 60 degrees. So is that understandable? So you see, this problem is not hard, but you need to use these things that I am telling you to improve your skills. Otherwise, if you don't pay attention to these things, you will repeat the same mistake over and over again, yes? So you see, the ideas that you learned in Math 1C is actually useful here when I am solving this problem. The point is that you need to change the point of your point of view about the problem, yes? Is that clear? Okay. Now, let us go to another problem. Of course, this now it needs a little bit of memory. I don't know, but let me write this one as well. So here, I would say that, let me write example. course, you have your notebook in front of you, and usually the exam is always open book and open notebook, so you can use them. So the point is that use your notes to be able to solve this problem. So I would say let U hat, V hat, do you remember what is the meaning of this hat notation? And W hat be unit vectors. Do you remember? I use this symbol hat when I am facing a vector which is of unit length. So to emphasize that I have a unit vector, instead of putting an arrow, I put this hat thing on top of it. So let U hat, V hat, and W hat be unit vectors. And this is very, very simple, such that so U hat plus V hat plus W hat is equal to 0. Determine U dot V plus V dot W plus W dot U. So we want to determine this. This is very simple, I think. I will pause the video and wait for you. When I wrote this, I didn't think about that you want to solve it geometrically. So that's good. Let us solve it in two different ways. Let me first solve it in the way that I actually aiming for. So I wanted to use this algebra. So I would say that when you tell me that the sum of these three vectors is equal to 0, what can I conclude? I can conclude that the norm of this vector is what? Is number 0. Yes? And then this means that this number to power 2 is also 0. Is that understandable? So I'm solving it algebraically. And then I don't know how many of you remember I told you that some algebraic identities will actually are also true when we go to vectors, yes? So one of them, of course, you need to understand what is the differences. Do you remember if I had 3 numbers in algebra to power 2, we had a formula for that. The first one is squared, the second one is squared, the third one is squared, 2 times the first one times the second one, 2 times the first one times the third one, and plus 2 times the second one times the third one. So that was the formula that we had. So I told you that, of course I proved it for you, but then you know what to do now. So it becomes, I cannot say the first one is squared, because this is nonsense, this doesn't make sense. But you remember, we proved this. This means it becomes the norm of the first one squared plus the norm of the second one squared, norm of the third one squared, plus 2 times the first one times the second one. Here will be dot the second one. And plus 2 times the first one dot the third one, and plus 2 times the second one dot the third one. Yes? So, but this is equal to 0 again. So from this, I concluded that, and I raised it to power 2, I concluded this one, and on the left-hand side, I expanded it in this form. On the right-hand side, I just copied and pasted at 0. Yes? But now if I ask you, do I know this number? Yes, because U is the unit vector, so the length of the unit vector is 1. 1 squared plus 1 squared plus 1 squared is 3. And then I can factor a 2 out. U dot V plus U dot W plus V dot W, yes, is equal to 0. And that is exactly my question mark that is wanted in the problem. So I move 3 to the right, it becomes negative 3, and then I divide it by 2. So it becomes negative 3 over 2 without any geometrical points of view. This algebraic solution, yes? So this implies that the question mark is minus 3 over 2. Yes, is that understandable? But that is also good that you brought this up. So let us solve it geometrically. How can I solve it geometrically? Can you explain? So these are unit vectors, so they are non-zero vectors definitely because their norms are equal to 1. They cannot be the zero vector. But from here, what can you conclude? I told you before, if you have 3 vectors whose sum is equal to 0 vector, how can I imagine them geometrically?
Triangle.
That would be a triangle. But because all of them are unit vectors, it means that this triangle is an equilateral triangle. Yes? But be careful, how should I draw them? That is very important. So if I draw u here, u hat, v hat, for example, if you started from here, this angle is 60. Yes, this is v. Can I draw w in this direction? But because in that case, u plus v plus w is not 0. So I have to draw w in this direction. This is a have to. Yes? Is that clear? So that would be the triangle. Okay, but now, so what you have done, you have calculated each one of them individually and then add them. Yes? So if I ask you what is u dot v, u dot v is the norm of u, norm of v, the cosine of the angle between u and v. If the norm of u is 1, this is the unit vector, the norm of this is also 1, but what is the angle between u and v? I told you that if you want to read the angle between 2 vectors, they should have been drawn from the same point. They are not drawn from the same point. U is drawn from this point, and this one is drawn from that point. So this means that you need to imagine, if I draw it from here, this angle, which is 120, is actually the angle between u and v. So this becomes multiplied by cosine of 120 degrees. But cosine of 120 degrees is minus cosine of 60 degrees. Yes, and it becomes minus a half. This is in trigonometry, we learned that, yes? And then hopefully you will understand, you will calculate the same thing here, the same thing there, and then you get minus a half, minus a half, minus a half, and then you add them, it becomes minus 3 halves, yes? So that's also a very good way to understand this problem. Any questions? So we have 2 or 3 minutes. I just want to finalize this lesson today. So do you remember, this is a good, so it reminded me something. Do you remember in Math 3C, we showed the cosine rule in triangles, yes? There we used the Pythagoras theorem to prove the rule. But we can do it simpler here, yes? For example, what is my goal? My goal is to show that A, B, C, in the cosine rule, this is A, this is C, this is B. For example, we want to show that A squared is equal to B squared plus C squared minus 2BC cosine of the angle A. Yes? That is the cosine rule. There is no vectors involved in this problem. That's a pure Euclidean geometry problem. But we want to use vector method to prove this. And this is very natural here. Why? Because I hope that you agree with me that the vector AB plus the vector, let me write it exactly the one that I want. So I would write, do you agree with me that vector BA plus vector AC is equal to vector BC? Do you agree? Even if you don't need even to look at the picture, because this is the Charles rule, yes? This A and this A are cancelled, so it becomes BC. But if you want to see it in the picture, BA is this vector, AC is that vector. So let me just, even though I didn't have any vectors at all, but I myself say that, okay, let us consider this the vector, BA, and this vector, and then the sum becomes, yes? And now, if 2 vectors are the same, it means that the norm of this vector is equal to the norm of that vector. Yes? And if the norm of this vector is equal to the norm of this vector, it means the norm squared is also equal to the norm squared. But there is a rule for that one. Do you remember? It becomes like the first identity, yes? the norm of the first one squared plus the norm of the second one squared 2 times the first one dot the second one, and this becomes the norm of BC squared, yes? What is norm of BA? BA is this vector. I showed the length by C, so instead of this I can write C squared. The length of AC squared is B squared plus, on the right hand side, the norm of BC squared is A squared. So you might say that this is the wrong sign, because in the cosine rule I should have a negative sign, but that's exactly the same story that happened there, because this becomes 2 norm of BA is C, norm of AC is B, cosine of the angle between vector BA and vector AC. The angle between vector BA and vector AC is not this angle, yes, is that angle, which is 180 minus the angle A. So this you have to write plus, but cosine will be cosine 180 minus A. But cosine on 180 minus A is minus cosine A, and then you get the formula for the cosine rule. And this proof is much simpler and more straightforward, yes? Do you remember, if you go back to Math 3C, when we wanted to prove this, we have to use Pythagoras theorem in 3 triangles and connect them together. But here it comes very naturally when we go to the dot product. So you see, even though the starting problem was a pure geometric problem, but we were able to use vector method to solve the same geometry problem in a simpler way. Yes? Okay, so tomorrow definitely we will finalize this lesson, and the next lesson that we will follow after the break would be another product between vectors. Then the problems become much more fun, yes? And yeah. Any questions? Yeah, every now and then think about those problems, yes? I have written that is also part of the course, but nobody even knows that I have published them, yes? How many of you have seen the questions? Yeah, good. So there are some fun problems. I will not give those kinds of problems in the exam, of course, they are sometimes hard, but it is good to take 1 or 2 of them, try to think together about those problems. That would be very helpful. Thank you.